Good afternoon everyone. My talk today is on sustainable fishing and technology. What's my interest in this topic? Well, first and foremost, I'm a technologist. One of the first computer programs I ever wrote was a fishing game in Visual Basic in 1992. And the purpose of the game was you were a fish, and the goal was to find food, to survive, to avoid getting eaten by sharks, and getting caught by fishermen. So the issues around fishing and the ocean have always been interesting to me from an early age. Right now, I'm working in software and data. I work just down the road in a financial institution, a world away from fishing and fisheries. I'm not a marine biologist, I'm not a marine engineer, but I have an interest in the marine world and the issue of sustainability. Before we get into the depths of the presentation, I have a few personal thoughts on the parallels between fishing technology and software, and they are quite related in some ways. If we consider ourselves as software developers, we want to build systems. We want to build systems that are efficient, that are scalable, and that run as fast as possible. And we want to use every possible tool and technique to make our systems run quickly, like parallel processing, multi-core GPUs, and so on. And I put it to you that fishing is actually not that different. At least from a commercial point of view, design principles such as speed and scalability in fishing technology is really important for commercial companies to have the right set of tools to maximize their catch. So I'm interested in the technology, but perhaps more so in the issues and the conflicts that the technology advancement raises and how we can set about to solve these issues. Fishing technology today is massively scalable, massively automated, and intelligent. It is an engineering success, but it's not necessarily desirable or successful from an environmental standpoint. And in fact, as we shall see, there are certain tech innovations that have led to the endangerment of some species. So this engineering mindset of optimizing for speed, scalability, efficiency doesn't automatically consider other issues like impact on environment, impact on societies, and also specifically on fisheries, which are finite resources and take time to regenerate. So as technologists and as engineers, I think we need to rethink our default behavior and be more sensitive to some of the wider issues surrounding the creations that we make and our inventions. And that's one of the reasons I'm really excited about the Fishackathon, because it's combining quite uniquely the values of technological progress and innovation with environmental and social responsibility. So I'm going to be focusing on the marine environment, the oceans. Yesterday we heard from Miranda Johnson at The Economist, who talked to us about innovations in the deep ocean, such as ocean drones and fish aggregation devices. I'm going to be talking more about coastal innovation and competition with traditional techniques. Less on the deep ocean and more on the coastal communities who are dependent on fishing and how innovation impacts them. There are other aspects of fishing, such as inland fishing, mainly freshwater, fish farming, and other farming of other aquatic material, like seaweed, crustacea, and so on, which I won't cover, but we're going to be biased a bit towards the coastal innovation. So, overfishing as an issue, we tend to think about overfishing as a 20th or 21st century problem that's caused by population growth, by the demand for fish, better trawlers, better technology, and automation of fishing processes. But actually, it's a much older problem. Even in the 1800s, overfishing was an issue, and also a stimulus for innovation. Had there been a Fishackathon in the 1800s, perhaps this might have been the result. This is a painting from the Maritime Museum in Greenwich. The boat with the red sail is a Brixham trawler named after the fishing port of Brixham, which is still an active fishing port in Devon on the English Riviera. It was developed in the 1800s to deal with the problem of a shortage of fish stocks in areas close to the coast and enable the fishermen to have a fast and sturdy means to get into the deeper waters where there were more fish. And very similar to what we see with other resources, such as oil in the North Sea, where we've exhausted all the immediately reachable resources and are forced to go further and further into the ocean to exploit the remaining reserves. So, with the invention of this trawler, people could stop thinking temporarily about the issue of overfishing, because there was always more fish further and further out at sea that could now be reached through this new technology. However, at this point, something critical happened. This was the Industrial Revolution, the age of steam. Suddenly, fishermen wanted trawlers that ran on steam. But here's the key point. Sailing ships didn't go away, at least not immediately. Including in this painting, there's also a steamboat at the back. We have different technologies from different eras that are operating and competing in the same physical environment. So it's an unequal environment for the fishermen. And it's exactly the same what we have today in technology. We have HTML5. It doesn't mean we stop using HTML4. We have Java, but we still have systems in COBOL. It takes a long, long time for legacy technology to fully go away. So the one point I want you to take from this slide is to imagine different fishing teams using different technologies operating in the same environment. And what sort of issues does that cause, and the tensions that it might create. So the point of this slide is to reinforce the fact that traditional techniques don't go away. You've heard about seining, which in broad terms means sticking a net vertically in the ocean with weights to hold it in place, and the fish get enclosed in the net. And this was something that was already practiced in ancient Egypt and ancient Greece, and beach seining methods are used today by traditional fishermen. Around the 1950s, it became commercially possible to do the same thing on boats because of the motorization technology allowed motors to have sufficient power to pull in the catch. However, today, both these so-called artisanal fishing techniques and the more modern methods of seining and purse seiners and all the other ships that use the same technique coexist. And again, the technology moves forward, but the legacy technology doesn't go away, and the people who are dependent on that legacy technology and legacy methods are forced to operate in an environment where they're competing with more modern methods. And incidentally, there was another issue of bycatch with this, but there was already a presentation this morning, which you might have seen on bycatch, basically other species getting captured, and that problem is prevalent both with the traditional and the non-traditional methods. One of the things that really interests me is the development of floating factories for fish. These are built on the premise that more processing of the fish is done at sea, and automating all the processes associated with fishing. It has its roots in whaling vessels. So the image on the left is the Nishin Maru, which is a Japanese whaling ship. You can see the rear slipway where they pull the whales. These ships evolved from the demand for whale oil, and the realization that a lot of the whales materials were going to waste. They wanted to extract more products, and they did it by implementing the technology while at sea. And the widespread use of these ships, which are not that common now for whaling, is the reason why whales are endangered today, because they were just able to harvest the whales at such a rapid speed. Now the use of these ships has migrated to other species. I've actually been aboard some of the more modern factory ships, and it's truly awe-inspiring to behold. For one thing, they've got massive hulls which dominate over all the other traditional fishing boats. They have a bridge with all the navigational instruments that can track and even predict the movements of shoals of fish. So they can program the autopilot to navigate automatically to the most productive areas of the ocean. And again, contrast this with the simple methods that traditional fishermen will be using. Simple techniques like observation of the movement of seabirds, observing the changing coloration of the sea to enable detection of shoals. The use of sonar and AI is something which really changes the whole dynamic, and it's very hard for the traditional fishermen to compete. The other aspect of these ships is that they have a lot of automatic processing on board. So as soon as the fish come out of the sea, they come into the factory, they're processed along conveyor belts, and essentially robotic infrastructure can then package them into boxes with various languages based on the export market, and that whole harvest gets taken away to those markets and not for the local communities. And if you're a fisherman operating those waters, that's a very scary thing to behold. So just to talk about that point a bit more, because I'm quite interested in factory ships, I wanted to understand a bit more about where they operate, and there are various sites online that you can track vessels. I'll take this to the center there, Sardinella. In Northwest Africa, you've got two species, round and flat, around Senegal. And just to give an idea of the importance of fishing to these cultures, the name Senegal actually means our boat, which sort of highlights the importance of marine life to the country, and also the national dish is fish and rice. So fishing is really core, and the presence of all these factory ships can at times be a threat to the local communities. We also have jack mackerel on the Chilean coast. We've got tuna in the North Pacific. And then we've got some newer markets. For example, Alaskan pollock, which comes mainly from the Bering Sea. That is now the second most harvested fish on Earth in terms of total catch. We've got new markets opening up in the Antarctic for krill. The world's largest floating fish factory is being built as we speak for Antarctic waters to supply krill for manufacturers of omega-3 health supplements. And the declining reserves of krill are also a threat to some of the local ecosystems, including Antarctic penguins. So with that, I've got my final slide. I'm going to conclude with a case study of the Benguela Current. So the Benguela Current, and I'm not a marine biologist or climatologist, but just from my interest, also traveling to that region, it's a system of ocean currents and trade winds that leads to very fertile waters. So the whole coast of Africa is fertile ground for fishing, but you can see from this picture, which shows chlorophyll concentration in the ocean, that it's extremely rich along the southwest coast of Africa. And that's a justification for many countries to be interested, to send their foreign fishing vessels there to harvest the ocean. So I've written a bullet point. The first bullet point, man versus machine, is basically about the struggle of the traditional fishermen with the foreign factory ships who can harvest the fish at a large scale and then export it back to the home country, such that there's even a shortage of fish in the local countries. Now, one of the social implications of this is local people want better technology. They want to catch more fish. They want to make more income, and they want to make it easier for themselves to compete. So that is happening. There's the sale of these trawlers to these countries. But if you imagine a future where everyone has these super powerful ships, the next battle is going to be man versus the ocean, because there's only so much you can extract from the ocean before it becomes unsustainable and you have a threat to the local species. So there's a capacity constraint, we can say. Various solutions are being proposed. Some to do with monitoring vessels entering those waters, seeing whether they have permits. I think that's one of the challenge questions. Quotas, also policy changes like returning a percentage of catch to the local communities. That's also being proposed and implemented in some of the areas. But it remains to be seen what other innovations or other solutions might yet happen. So that's the end of the talk. I hope you've enjoyed it. I hope it's kind of given you a bit more context to sustainable fishing. And if you've got any questions, feel free to ask. And I look forward to interacting with some of you as well through the rest of the day. Thank you.